Welcome back to Remote Explorations, guys. It's me, Sinjan, again. And as promised, I am bringing the second part of the solutions of UGA paper of ISI 2025 BStat BMaths entrance examination. So, yesterday, in my yesterday's video, we did solutions of question number 1 to 10, of which I had left two questions, probably question number 6 and question number 8, which I had said I would be doing in a separate video since I think those questions were a bit too tough in comparison to the series of questions from 1 to 10. In today's lecture, in today's video, from question number 11 to 20, I will be solving them. I have solved them. I will be guiding you through the solutions. Due to lack of infrastructure, due to which I am not being able to solve it live. Of these 10 questions, I have left 3 questions, which again I think, of which 2 I think is a bit tough, and another one I would like you guys to try it once, since it's basic. It's a really easy question, a little bit of trickery, and you will be able to do it. Other than that, I have solved 7 questions, and my focus has been based on mainly intuition. I have tried to solve maximum of the questions through proper intuition and proper intelligence and proper thinking without doing much calculations or something like that. So without any further ado, let's get started. Question number 11. Yeah. So in this question we were told my A0 is given to be 0, A1 is given to be 1, AN is given to be, AN basically is an expression. AN is equals to 5AN minus 1 plus AN minus 2, where my n is greater than equal to 2. For this expression to be valid, we need to find matrix that is basically determinant of A101, A100, A100 and A99. Whenever we see these questions, our basic first thing which any novice or anyone or anything, before anything comes into our mind, we basically try to find out the values and see if we are getting any pattern or not. Cool. So by putting out the values of A0 and A1 and A2, I find out my A2, similarly A3, A4, A5 and so on. Ultimately what we can see, you are getting some kind of pattern, some random kind of pattern, not an exact pattern, some 5 square or 5 to the power n or something, that kind of pattern. We are ultimately getting that. But if we try to solve the question based on only those values, like after we find out these values, what our basic thinking should be, we will be trying to find out a pattern among all the values of A. So then we will be using the same pattern to get A99, A100 and A101, then put them and solve. But believe me, this is going to be a huge process, an absolutely bonkers process. To avoid that, what have I done? I have considered a function theta n, which is basically an plus 1, an and an minus 1. Since my original function is basically in this form, so if I put my n to be 100, I get my A100, A100, an plus 1 is A101 and an minus 1 is A99. So basically, if the question comes down to, I need to find the value of theta 100. Now I have calculated the values of A1, A0 and A1 is given. A2, A3 and A4 I have calculated the values. Now my target should be to find out, these questions are made in such a way, they look big, they appear big, they are also big in some cases, but it happens in such a way that either you get a pattern between A0, A1, A2, A3, or you get a pattern between theta 1, theta 2, theta 3, theta 4 and so on. These questions are constructed in such a way, it's basically done to confuse the children and to make them follow a longer process, which ultimately will be helping them in the losing of time. So I find out my theta 1 by putting the values, which I get to be minus 1. Simple formulation. Theta 2 comes out to be 1. Theta 3 again comes out to be minus 1. and I haven't calculated theta 4 and theta 5 here, but if you see it, theta 4 comes out to be 1 and theta 5 to be -1 and so on and so on. So the pattern which we intended to find out in A0, A1, A2, A3 and so on, we are getting that in theta 1, theta 2, theta 3, theta 4 and so on. Cool. Therefore, what we can see, it's creating an alternating series basically. So my A1 or probably theta 1 is coming out to be -1, theta 2 is 1, theta 3 is -1, theta 4 is 1, theta 5 is -1. So basically odd, all the numbers or all the values of theta which have odd suffixes are giving the result to be -1, and even suffixes are given the result as +1. We need a theta with an even suffix. So theta 100 basically comes out to be 1, and our answer is hence option D. Nice question. I wouldn't say very tough, little bit of thinking. The main key or the main fallacy is to formulate a function based on the total matrix. Question number 12. We have three sides of a right angle triangle given in GP. We need to find the smallest angle. Easy question. It's very amazing to see these small conceptual things are being asked in ISI's examination. It's an easy question. It's a really easy question. So whenever three sides of right angle triangle, anything given 3 is in a GP, we hold them to be A, AR and AR square. Since my hypotenuse is the longest side in a right angle triangle, I keep it AR square. A and AR, you can change it accordingly, no problem with that. Following Pythagoras theorem, a square plus a square r square equals a square r to the power 4. We ultimately get this equation. Now here, if I bring this thing to my LHS and take my a square to be common, it is ultimately coming out to be a square into r to the power 4 minus r square minus 1 equals 0. Now my expression, basically product of two expressions is 0, so either one of them must be 0. Now my a square can never be equal to 0, since if my a square is 0, then it would signify my a is also 0, then all the sides I would be getting the value as 0, which is not possible. Hence the expression of r to the power 4 minus r square minus 1 equals 0. From here, using Sridharacharya's quadratic formula, we are getting the value of r square, which since cannot be negative is ultimately coming out to be 1 plus root 5 by 2. Now my cos theta, my options were given, two are in sine inverse, one is in tan inverse and one is in cos inverse. So I have taken this angle to be my theta. My cos theta would be perpendicular by hypotenuse. So, or sorry, extremely sorry, cos theta would be base by hypotenuse. So here it would be basically AR by AR square, which after calculating I am getting it to be root 2 by root over of 1 plus root 5, which is not there in the option, so this cannot be done. We calculate sine theta, which is perpendicular by hypotenuse. So after all the careful rationalizations and everything, my theta comes out to be sine inverse of root 5 minus 1 by 2, which is basically my option D. So that's the answer for this question. Very easy question, nothing sort of trickery or something involved. Question number 13. Two similar triangles, triangle 1 and triangle 2. We are given 4 conditions, S1, S2, S3 and S4. We need to tell which condition implies which one and which one not. So this question I think is a little bit, what should I say, conceptual. It's a very conceptually deep question. So I'm keeping it for last, for my 4th video, which will be coming on probably day after tomorrow if everything is alright. So I'm skipping my question number 13 for now. Coming up to our question number 14. What am I given? My n is greater than equal to 1. It's a complex number question. It's again a good question. Not very tough, not very easy. Actually easy, but it needs a little bit of trickery. You need to know the number of ways basically a complex number can be written. The Euler's form of complex number can be expressed. So let an and bn be such that an is not equal to 0, bn is not equal to 0. We are given an plus ibn whole to the power n is basically n into an plus ibn for n greater than equal to 0. Then we need to find out the expression. Okay. So we know my z is basically an plus ibn. And also this thing, you need to remember this thing, z can be written in the form of r e to the power I theta, which is basically r into cos theta plus I sin theta, which is the Euler's form or the trigonometrical form of writing a complex number, expressing a complex number. So according to the question, this is basically z, this is also z, so z to the power n is equals to nz. I bring my z to this side, z to the power n by z equals n. Same base, different powers, and in division, so we subtract the powers. So z to the power n minus 1 is basically n. Now z is r e to the power I theta, so r e to the power I theta whole to the power n minus 1 is n. Cool. What we do, we separate the terms. Now you can do something, you might separate the term and you can directly get the answer which I am getting here. So let me make you understand. We separate it. So r to the power n minus 1, I am comparing it with n. Now my r becomes n to the power 1 by n minus 1. And if we see the options carefully, unfortunately I haven't given my question pasted up here, or else I could be showing you the options too. In all the options, only in my option D there is a power of n to the power 1 by n minus 1, which is going to be my option D, and that is going to be my answer. And if you are not satisfied with this, you want to check more. Now this is basically a purely objective approach which I have told you. Cool. If you want to check it, you can solve this equation and I'm 200% sure you are going to get the same result as option D. I haven't solved it, I am keeping it a homework for you guys, those who are watching this video. So yeah, that's it. Good question. Now question number 15, a sort of, what should I say, pure formula based geometry question. This is a result which we often prove, which teachers often prove while teaching geometry, and which I during my year-long course, which I'll be starting from most probably June's first week itself, like the schedules and everything will be given in the first week itself. My channel will be becoming a full-fledged teaching channel then, along with beach में some kind of questions, conversations, and also a surprise for you guys. I am going to bring a very special guest to my channel for some extra information, some outer information, like you are gonna get more knowledge about it. I'm gonna share a post and everything else. So yeah, but it's a surprise. I'm gonna bring a very special guest in probably next week. So yeah, this question is a very formula based question. So my length of two sides of a parallelogram is given to be 2 and 3, and one diagonal is also going to be root 19. We basically need to find the length of the other diagonal. Now this formula is often derived while teaching geometry, which I will also be deriving. Its derivation comes from simple cosine rule, nothing very complicated. If you want, you can derive it. I will be deriving it while I will be teaching geometry. So this formula says d1 square plus d2 square equals twice of a square plus b square, which basically is d1 and d2 are my two diagonal lengths and a and b are my two adjacent sides. So now this is a direct hack for solving this question. You know this formula, you apply it, you get the answer in no time. But yes, it's going to be a little lengthy if you do not know the answer, or probably if you do not know the formula. So yeah, I apply this formula, putting in the values, simple plugging in, I get my d2 to be root 7, which is my option B. I won't be spreading away with this question. This is a purely formula based question. Question number 16. Tell what I have seen this paper. This paper appears to be quite an easy one in comparison to 2024's UGA paper, the one which I gave. So I am thinking this paper must be, the qualifying for this paper must be at least 8 to 9 marks greater than what was the cutoff of UGA in the year 2024. This is probably like the year 2023's paper, what I am thinking, because the questions are not tough. You cannot tell them to be tough. They are easy, they are conceptually deep, and they hit you where it hurts. That is at the conception. Yeah, obviously some questions are formula based, I absolutely agree. But yeah, that's a good paper. It's actually, I should say, towards the easy side. It's an easy side good paper. Now, my question number 16 is basically I'm given a function and I need to tell its maximum and minimum points. Okay. So my f of x is given to be 1 by 1 plus mod of x minus 1 plus 1 by 1 plus mod of x plus 1. So very easily x minus 1 equals 0, so my case will be arising at x equals to 1, and here also x plus 1 equals 0, then my case will be arising at x equals to minus 1. One thing which you can check is my f of x is going to be f of minus x. You can check it, since at putting minus x in this one, these two functions get interchanged. Okay. So if we get 3 different intervals, I can check it in 3 different intervals. Since my the total function is basically lying between 0 and 1, or probably it's not exceeding 1. So I can take my 3 cases. One case is less than 0, another one is 0 to 1, and another one is greater than 1. Though after I tell you the intuitive way to solve it, if you want to solve it in a more broader way, you need to go for differentiation. You need to apply calculus. But I am going to show you how, without calculus, how intuitively you can do this thing. So I have made my intervals. One interval is 0 to 1, another one is greater than 1, another one is less than 0. This interval I am least concerned with. These two are my main areas of concern. So greater than 1. If I put any value of, for my greater than 1, this x minus 1 is going to be remaining x minus 1. This thing is also going to remain x plus 1. So I get my function to be 1 by x plus 1 by 2 plus x. Between 0 to 1, this thing becomes negative, since this thing is only positive if my x is 1 or greater than 1. So my this thing becomes minus of x plus 1. Yeah. And similarly, this becomes 2 minus x and this becomes 2 plus x. So we calculate this, we get it to be 4 by 4 minus x square. Now, time for intuition. At x equals to 0, this function is basically giving the value of 1. And for any value, this function is going to decrease. See it properly, 1 by x plus 1 by 2 plus x is going to decrease for any value of x. For any value greater than 0 for x. So now what I can see, I'm going to take very nominal values. I have taken 0 to here, 0 and here, and now I'm going to take 1 here. See, if I put 1 here, what am I getting? The total value of this function becomes 4 by 3, and here it is 1. So 1 and 4 by 3. Now what we can see, here the value is less, here the value is more. Since we know my maxima minima, the wavy curve thing should be symmetric in nature, this is less, this is more, then this should be more. To maintain this pattern of wavy curve, you can differentiate it, no problem with that. I am fully confident if you differentiate it, you will be getting the same result. So this is ultimately what our graph looks like. You get a maximum value at 1, you get a maximum value at minus 1, and you get the minimum value at 0. You see the wavy curve is being followed. So hence my option should be option number D. Cool. Take 1 or 2 minutes to digest it. Good question. Intuitively, if you can solve it, then you are at a very good place. Take 2 minutes. Yeah. So next is my question number 17. What we are given fx, we are given three different cases of fx. So basically my fx, if you look at it properly, it's this signum function, it's signum x, where when x less than 0, the function takes the value of -1. When x equal to 0, the function takes the value of 0, and when x is greater than 0, the function takes the value of 1. We need to say about this function. Capital F of x is equals to integral -5 to x small f of t dt. So this basically is a dt here. We want to comment on f of t. Now let's make cases again. Three different cases are given up here. So we make the three different cases: x less than 0, x equals 0, and x greater than 0. Good question. It's a good integration question. Integration and function related good question, no problem about that. So when my x is less than 0, so my -5 is negative, x is negative. So -5 to x integral f of t dt. Now my f of t, we know for negative is always going to be -1, and here my x and -5 both are negative. So ultimately I can replace my f of t with -1. So my result comes out to be minus of x plus 5. Normal integration, nothing more. Similarly for x greater than 0, my -5 to x, so my -5 is negative, so x is positive. So ultimately when you are going to calculate f of t's integral, we first need to move from -5 to 0, cover the full negative value, then 0 to x, covering the positive value. So from -5 to 0, the function takes the value of -1, and from 0 to x, the function takes the value of 1. Which after calculating, I am getting it to be -5 plus x, or probably x minus 5. I don't need to calculate it at 0, at x equals to 0. I do not need to calculate it. What we can see here, this thing is giving me a negative slope of x, and this thing is giving me a positive slope of x. So my curve comes like this and goes up like this, ultimately showing a sharp turn at 0, which means it's a differentiable everywhere, smooth everywhere. See, it's smooth everywhere, but except we have a small nibble at 0, hence it's differentiable everywhere but not at 0. So my option D is correct. Again, a very intuitive way of thinking. If you want, you can actually draw the total curve of the thing, but in examination hall and also in UGS paper, you are not getting that much amount of time. So this is why, this is how you do this question. Again, take 1 to 2 minutes. If you are not convinced, or need to take a look at it once more. I have used the slope. The slope becomes very valuable for me since a straight line represents differentiable everywhere, and a small type of, what should I say, kink or a small discontinuity shows my non-differentiability. Done. Question number 18. This question I want all of you guys to give it a try. It's a good limit question. The form also I am telling, it's basically infinity to the power 0. Give it a try. It's a good question. If not, I will be doing it in my fourth video. Question number 19. We are given 4 integers a, b, c, d, which all of them are greater than 0, such that my a, b, c, d is 9. So we need to find out the number of different ordered triplets a, b, c, d. A very good and a very cool usage of, what I should say, permutation and combination. The number of solutions वाला formula उसका बहुत ही अच्छा use होता है इसमें. So let me tell you before we solve this question, this type of question is probably given in one solved example, in one illustrated example of Sengage's permutation and combination. That's my algebra part as far as I can remember. The product way, how to solve a question when the product is given. So yeah, first of all, as a novice, I will be factorizing my 999. And in most cases, you know what happens? This thing comes down to prime factorization of two numbers only. Like you see 999, it has ultimately come down to 3 cube into 37 to the power 1. Now, I take each of this integer to be some form of 3 to the power k1 into 37 to the power k2. B is equals to 3 to the power L1 into 37 to the power L2. C is equals to 3 to the power Y1 into 37 to the power Y2. D is equals to 3 to the power Z1 into 37 to the power Z2. My motive here is to convert this problem to the number of solutions wala problem from permutation and combination. I multiply these numbers as I am given in the question. A, B, C, D equals 999. So 3 to the power k1 plus L1 plus Y1 plus Z1 into 37 to the power k2 plus L2 plus Y2 plus Z2 equals 3 cube into 37 to the power 1. Comparing the coefficients, the place where we get the number of solutions wala formula. K1 plus L1 plus Y1 plus Z1 equals 3, each being greater than equal to 0. K2 plus L2 plus Y2 plus Z2 gives me 1, each being greater than equal to 0. Now this thing must look familiar. We are given this, we need to find out the number of solutions possible when each number is greater than equal to 0. For greater than 0, my formula was n minus 1 c r minus 1, and for my greater than equal to 0, my formula was n plus r minus 1 c r minus 1. If you haven't done this, see one of my videos. I have forgotten on which video I taught you. I have actually showed the derivation of this formula and also implicated, and probably, if I am not wrong, I have forgotten, I have solved one product type question also. So greater than equal to 0 वाले formula में क्या होता है हमारे पास? We have the formula of n plus r minus 1 c r minus 1. So you put this n plus r minus 1 c r minus 1. This is for my first equation. So we get 20 number of choices possible in my first equation, this thing, and for here I am getting my 4 number of options available. So obviously you aren't going to add, you are going to multiply. So 20 into 4, 80. So there are total 80 number of tuples possible of the form A, B, C, D, and my answer is option C. Good question and easy one, I should say. Really easy question. Question number 20, again a good question. I am keeping it for you guys. do try to solve it. If you want, you can write it in the comment section too, no problem with that. So yeah, that's for today, I guess. So question 11 to 20, of which I have left 3 questions, of which 2 are genuinely tough and another one I want you guys to try before I show you the solution. It's a good limit question. It's probably a little more harder than CBSE ones. So yeah guys, that's it for today. Tomorrow I will be coming up with the video of question number 21 to 30. So still till now, after solving this 20 questions, I have found 5 questions or probably 4 questions which are a little tough. So I will be solving them in a separate video. So yeah, that's it for today. Take care. Do like, share and subscribe to this channel. I with much preparation and schedule making and everything on point, I'm going to bring you a superb course for ISI and CMI's exam cracking for the year 2026, which will be starting from June 1st week itself. So do mark your calendars. So today is basically 30th May, so probably day after tomorrow only I'm gonna start it. And if it's a Sunday, I will be sharing up updates very soon. Total schedule of how frequently I'll be uploading videos. I'll be probably uploading videos daily, or if not possible, then a single take gap and I'll be uploading. I will also be giving you mocks, your practice assignments, everything. It will be a totally arranged course, and most important, it will be free of cost. So don't you worry about the cost. It's a superb course designed for ISI, and I'll be teaching there myself. At least I will be starting there myself, and after that, if possible, I will be trying to see if I can bring someone on board for some lectures. So yeah, that's it for today. And also probably in my next week I am going to bring a very special guest to my channel. So yeah, do click the notification bell icon for that, so that you do not miss any updates of my channel, any sort of post or any sort of poll I put in. So yeah, that's it for today guys. See you soon. Goodbye. Take care.